Hi guys, let's talk about the specific factors affecting the type and rate of weathering. Here I have two, rainfall and temperature. So here's a diagram for you guys that you guys have to know for your exams and know how to draw and know how to explain it. It's called the Peltier's diagram. It shows how temperature and rainfall affects your type and rates of weathering. So as you can see here, let's look at the temperature itself. At low temperatures, you get physical weathering, mainly physical, moderate physical, strong physical, moderate physical, slight physical, and then frost action, freeze thaw is still physical. And above zero, at warmer temperatures around 20 and more, you get chemical weathering. So the shift from physical to chemical is because of temperature. As for rainfall wise, as you can see, the more rainfall you have, this side is more rainfall, this side is no rainfall. The more rainfall you have, the faster the rates of weathering. So slight weathering with very little rainfall, and especially for chemical, the trend stays with slight, moderate, strong. So as you increase your rainfall, the faster the rate of chemical weathering. As for physical, the patterns maintains for up here. You see slight, moderate, and strong. But around this temperature, this 0 to -20, it kind of breaks down a bit. So yeah, and also this frost action is really important because it occurs at 0 because this is average temperature, but it occurs if you have average, it generally kind of fluctuates around 0 degrees. That's why you get frost action. Freeze thaw, you need the fluctuation. As for this place, it doesn't exist because you don't get places with very cold temperatures and high rainfall because that can't possibly happen. You don't have any convection currents. So yeah. So know how to draw this diagram, visualize it in your head, and then remember how to draw it. Know how to explain it. Explain how your types of weathering changes as you move your temperature and how your rates are affected by your rainfall. Very little when there's no rainfall at all for both. So let's move on to rainfall and temperature specifically, why they're so important. Rainfall is essential because water is essential for all weathering processes, and also helps get water to places that may be unreachable. So why is water essential? Because for all chemical weathering processes, as you may know, you need water, and for biological, you need water to stimulate your plant growth. As for physical, it's more nuanced, it's more niche. Freeze thaw and cell crystallization, we all know you need water. But as for dilatation, the reason why you need rainfall and water in the first place is because it requires the erosion of the top layer of soil. And what helps you with that is rainfall with water splashing down, helping you erode, which we'll cover in our next topic about the movement of water on cliffs. So be sure to look out for that. And also why onion skin? Onion skin because you need the differential pressure exerted on your rock because of water helping you dilute the temperatures in some areas, helping you have extreme temperatures in some areas, and this differential pressure is the reason why onion skin weathering actually occurs. Gets water to places that may be unreachable. That basically means in mountains, you don't have your ocean splashing water on. You don't have a lot of streams that can get water and wetten your area. So rainfall helps you get water to maybe flatlands or maybe mountains. So this graph, you don't have to know the graph. I'm just visualizing for you guys. So here's the rate of weathering and here's the rainfall. Let's look at the red graph first. The red graph, it's for chemical weathering, biological weathering, and dilatation. So you have little over here and increases and then it plateaus. So it kind of follows this trend over here. You have slight with little rainfall, then moderate, so it starts to increase, and strong, and it starts to peak around here. The reason it plateaus is because there's other determinants of the rates of weathering. You can't just exponentially increase your rates of weathering because there's other stuff like temperature as well. Chemical, because more rainfall, then you get more coating of your minerals for chemical weathering. Biological, more rainfall, more plant growth. Dilatation, more rainfall, more erosion. However, up to a certain point, because rainfall is not the only erosive power. There's also rivers and other factors that help with dilatation. Let's look at the green graph over here. It's for freeze thaw. So as you can see, freeze thaw, you need water to get into cracks, freeze, and then melt. So you need rainfall. So as rainfall increases, you get a peak. And the reason why it starts to decrease is because if you have a lot of rainfall, it may over dilute, and it may dilute the temperature so that the area may not fully freeze, and because there's so much water, right? And therefore you get a dilution and you don't get as much freeze thaw with really high rainfall, but it does increase it. As for the blue graph, it's onion skin and soil crystallization. As I mentioned about onion skin, it is essential for water. So at 0 rainfall, you don't get any weathering, but it starts to peak. Onion skin, I've explained why. Soil crystallization, because you need water to get into cracks and then evaporate, and it does help with that rainfall does help with the water getting on and getting into cracks. The reason why it starts to decrease, the rate of weathering starts to decrease with higher rainfall, is because for soil crystallization, with a lot of rainfall, your solution, it gets diluted. So you don't have crystallization, you don't have a lot of evaporation, because once the water has evaporated, more rainfall will fill it in and dilute it, so you don't get crystallization. As for onion skin, if you have a lot of rainfall, it coats the entire rock, it moistens the entire rock and wets the entire rock, and therefore you don't get a differential pressure because everywhere is wet. Everywhere will increase and decrease in the same temperature and expand similar. So this is how the rainfall affects your rate of weathering. You don't have to know this graph, but it's good to understand, visualize it. And now let's move on to temperature. So temperature-wise, Van 't Hoff's law is something that affects the chemical weathering, of how temperature affects chemical weathering. For every 10 degrees increase in temperature, the rate of chemical weathering increases by 2 to 3 times, up to 60 degrees Celsius. So you can put that in to explain why higher temperatures there's greater chemical weathering, because it gives energy for reactions. Temperature gives you the kinetic energy, which is essential for chemical reactions. Temperature, also higher temperature stimulates vegetation. As you can see in tropical areas, your enzymes are more active during photosynthesis. Therefore, higher temperatures, more vegetation, more biological weathering. But temperature itself is not just high and low. You can talk about how it fluctuates, and that's why it's so essential. And the frequency and extremes is the one you should talk about. Frequency for freeze thaw, the more frequent the fluctuation between 0 is, the more freeze thaw you have. And extremes, the more extreme the temperatures are, the more onion skin you have. And also temperature affects rainfall. As I mentioned just now over here, you can't have very low temperature and a lot of rainfall, because you need high temperatures to bring your evaporated water up and cause rainfall. And so that's how you can argue that temperature is more important than rainfall. So this sums up for the specific factors such as rainfall and temperature that affects the type and rates of weathering. Make sure you know your Peltier diagram, and that sums it up for the weathering chapter, and I'll see you guys in the next video.